All right, folks, it's Bass Action back in action. In this video, we are going to go over some basic properties of our trig functions and their graphs. Don't worry in this video about how you would create these graphs. The purpose of this is to get some basic properties under your belt and then just start to familiarize yourself with what the graphs look like. So when we do get into how to graph them, you're prepared and have an idea in mind of what your graph should look like when you're creating one on your own. All right, jumping into our first one, we're going to have our sine function here. So the first thing we want to think about is whether sine is odd or even, and this is a tie back to what we did in first semester. Remember, odd functions will have rotational symmetry around origin. Even functions will have a y-axis symmetry. So you should be able to easily recognize on this graph that this function is going to be odd. And then that's just a property that you want to become familiar with. When we look at this graph, these actually have arrows here on the end. So the domain of a sine function will always be negative infinity to positive infinity. And the range of the parent sine function is going to be from a -1 to a +1. Just again, like we did last semester, reading from our graph. It only goes this low and only goes this high. Then the next thing that we want to talk about is it's called a periodic property, and it's how often that the function repeats. So when we look at this going on and on, we can see that this part here looks just like this part here, and we've got these same low spots. This is what is called the periodic property, and that the graph is going to just repeat itself over and over again. So if we look at just a single portion of it, we've got this part right here that continues to repeat itself over and over again. That's the periodic property. So what we look at is we say from 0 to 2 pi completes a full cycle of it. So our graph is going to repeat, sine is going to repeat every 2 pi units, okay? That means that if you have some angle measure plus 2 pi, you're going to get the same value over and over again. The value here at 2 pi is the same as the value at 0, okay? So that we can fill this in and say sine of theta plus 2 pi is the same as just sine of theta, okay? Then we're going to look here at the cosecant graph. First of all, thinking, is it odd or even? Notice that we've got this part right here is the same as this part right here, and that's going to, again, be our rotational symmetry. So cosecant is going to be odd. The next thing that I want you to notice is that the cosecant graph has asymptotes in it, okay? The reason that the cosecant graph is going to have asymptotes is, remember, cosecant is the reciprocal of sine. So anywhere on the sine graph that it equaled 0, on the cosecant graph, it's going to have an asymptote because 1 over 0 is going to become undefined, thus creating an asymptote. Because it has all of these asymptotes, when we express the domain, it's going to look a little different. We're going to write the domain as x such that x is not equal. We want to identify those asymptotes. So what we're going to do is we're going to say 0, where the first asymptote is that we can see, plus pi k. Now, we're going to do a lot of practice with this later. Remember, the 0, as I just said, is an asymptote. There are many asymptotes here, an infinite number. I just picked the simplest one. And then the pi is going to be the distance between the asymptotes. And we're just trying to get comfortable with this right now. We're going to do lots more practice later. The range, you can see that we have this whole gap between here that there are no values. So just like with our sine function, we could put some little arrows on these little pieces here. So when we express this range, we're going to say it goes from a negative infinity all the way up to a -1, parentheses and a bracket. We can see that we've got values there. And then we're going to start over at a +1 and go to positive infinity. The cosecant graph is also going to repeat every 2 pi, just like the sine graph did. And if we want, we could even, just like we did before, we can kind of highlight what one, it's called a period, is going to look like. So this would be 1 period. Okay. Now, cosine and secant are going to be very similar, so this one might even go a little bit faster. Okay. So first we're going to think about odd versus even. The cosine function, we can see, has this nice y-axis symmetry. It's exactly the same on each side of that y-axis. Again, if you want to put your arrows there, that's often helpful. So cosine is going to be even. Its domain, since it has those arrows, negative infinity to positive infinity, range is the same as the sine function from a -1 to a +1. When we look at when it repeats, I'm going to start here. And then we've got this piece right here. So cosine is also going to repeat every 2 pi. And that means that cosine of theta plus 2 pi is going to equal cosine of theta. Oh, I just remembered. I missed this one up here. This cosecant of theta plus 2 pi is the same as the cosecant of theta. In class, we'll go over how this is going to be useful for us. Then our secant function, remember, is the reciprocal of cosine. So again, you can see this is going to have asymptotes. Anywhere that the cosine function was 0, when we do its reciprocal, it will create some asymptotes. Just like we did before, we could highlight a particular period. So I'm going to grab couple asymptotes here. This is what a cosecant period would look like. It would have 2 of those pieces. Its domain, similar to what we did for the cosecant function, is going to be x such that x is not equal. We're going to pick one of our asymptotes. I'm going to choose this asymptote at pi over 2. Plus, then we're going to look at how far apart are the asymptotes, and they are going to be pi units apart. And then we're going to put a k. I'll talk more about that k in class. It's going to be just represent a whole number. So the pi over 2 is an asymptote. The pi is the distance between them. And we're going to have full lessons on how to actually create these graphs yourself. The range for the parent function is going to be the same as what we had for the cosecant, negative infinity to a -1, inclusive at these -1s. Remember, those were arrows, union. And then we're going to start back over at a 1, inclusive, because I've got a point there, to a positive infinity. Oops, meant to do a parentheses there. The secant function is going to repeat every 2 pi as well. Okay, and that means that secant of a theta plus 2 pi, we can essentially ignore it and just think of that as a secant theta. Last ones we're going to look at are going to be tangent and cotangent, and I'll be honest, these are often students' most complicated ones, so I would definitely spend some time looking at how these are the same and different. Our tangent function, we can see, has a nice rotational symmetry here around origin, so it's going to be odd. Its domain, as soon as you see that you have these asymptotes, we're going to have a more complicated domain. So we're going to have an x such that x is not equal. We're going to pick one of the asymptotes. I'm going to choose pi over 2. Plus, now we want to look at how far apart are the asymptotes. So if I'm going from a negative pi over 2 to a positive pi over 2, they're going to be pi units apart. Again, if you want to remind yourself, this is an asymptote. This is a distance between the asymptote. Its range, just like our other graphs, when we get to the edges, these have arrows. So its range is going to be a negative infinity to a positive infinity. We can see that this tangent function is going to repeat. Let's grab a single period. We want to include the asymptotes so that we remember it's part of the process. It's going to repeat every pi units. So now tangent at theta plus pi, notice this is different than the last 4 that we've done, is going to be tangent theta. Cotangent, when we compare these graphs, what cotangent should look like is actually, it's a reflection. So notice this one looks like it's going in the negative, but also the asymptotes are shifted. So they look very similar, but they are dramatically different. The cotangent function is odd though. Its domain, x such that x is not equal. Pick an asymptote. I'm going to choose the easiest one of 0. The distance between them is also still going to be pi, so pi k. You can write that reminder. This is an asymptote. This is the distance between them. Its range, just like tangent, is negative infinity to positive infinity. They do repeat every pi units. So cotangent of theta plus pi is cotangent theta. And the last thing that I'm going to do here is I'm going to highlight a single period of cotangent so that you can start to get that in your head of what that looks like. So what you should do is you should spend some time doing some compare and contrast of these graphs, get comfortable with these properties. And now that you're done with this video, if you've got this on the cardstock paper, you could cut this apart and make little flashcards to study for yourself if that's something you find helpful, or you can keep it all together as a single piece of paper. It's totally up to you.